Good afternoon, students. Now in today's class, we have to discuss with that attributes. So what are the data objects and data attribute types? Already we have to discuss in last class. Now in today's class, we have to discuss with that what is the continuous attributes and discontinuous attributes or discrete attributes. So already in last class, we have to discuss with that discrete what are the attributes you have to use in the data objects. So here you have the type of the attributes you have to represent. That is the nominal attributes and binary attributes, ordinal attributes, and numeric attributes. Nominal attributes already in last class we have to discuss, that is relating to the names. Nominal attributes mainly you have to represent the values of the nominal attributes or symbols or names of the things. You can call it as nominal attributes. And the second one is the binary attributes. That is binary attributes is nominal attributes. There are only two categories, either straight 0 or 1. That is the two binary attributes we have to represent. And the next one is ordinal attributes. In ordinal attributes we have to represent an ordinal attribute is an attribute which is possible values that have a meaningful order or ranking above them. So which attributes we have to represent it as a ranking and meaningful order we have to specify, that is the ordinal attributes. So last one is the numerical attributes. The numerical attributes are quantitative, it is measurable, and quantity we have to represent the integer or real values. So these are numerical attributes. Again, you have to divide into two types. That is the interval scaled attributes and the ratio scaled attributes. Interval scaled attributes means the values you have to represent the attributes in the form of in between. That is the interval scale attributes, and then you have to represent the ratios. That is the 0 point ratios you have to represent it as another type of numerical attributes. Numerical attributes are divided into two types. One is the interval scale attributes, and second one is the ratio scale attributes. And next one is the summarization of the data. So in data summarization of the data, descriptive data summarization, the whole data object information you have to represent it. Consolidate overall picture of the data you have to represent it with this descriptive data summarization. Here main this data summarization you can process the data process. So, for example, See here, that is the mainly in a data processing, in data pre-processing, where you have to perform this data pre-processing. So for every data have the noisy data. For example, you have to take inconsistent data. For example, some of the fields are not filled with the values. Some of the fields are we have to fill with actually we have to represent it as numerical, but we have to enter the character values. So that is the noisy data you have to occur in all of the data objects. So now you can process that data. We have to eliminate those type of data processing. After data pre-processing is processed in a given data objects, then after you can represent that data in overall picture. Like for example, you have to take the salaries of a particular organization of those employees. You can find out the mean mode, median values we want to find out. So here you can here you can find out the overall picture of the data. That is simply you can call it as data summarization. Data summarization techniques can be used, define the typical properties of the data, highlight which data should be treated as noise and outliers. So here the data properties generally we have to represent centrality and variance. And data properties mainly we have to represent median and quantifiers. First one is centrality. Use the measures such as the median value, and similarly the variance use the measures such as the quantiles. So from the data mining point of view, it is important examining computer facility, how we can efficiently we have to compute it for the given date, that you have to represent it as data summarization. That is the overall picture of the data you have to represent it with this data summarization. See here, measure how to measuring the central tendency. Here mainly we have to represent that data central tendency and variance. See here how to is measure the central tendency. The basic statistical description of the data you have to represent it with the two ways. One is the measuring the central tendency. Measuring the dispersion of data. So first one you have to discuss with that measuring the central tendency, whereas in the basic statistical description of data, first one is the measure the central tendency. Mainly you have to follow, you have to find out the values, mean, mode, and median values in the central tendency. But whereas in the second one, that is the measuring the dispersion or variance, we have to represent it as dispersion of data. In that case, you have to discuss with that range, quantiles, variance, standard deviation, and interquartile range. That all things we have to discuss in the measuring the dispersion of data. These are the two types of data we have measuring the properties we have to use in basic statistical description of data. First one is discuss with that measuring the central tendency. Yeah, first one you have to find out the mean value. Generally, mean represents the average number of that is the sum of the values by count. That is simply you can call it as average. So here a distributive property when a distributive measure can be computed by partitioning to the in the data into the smaller subsets like summation of data by count the data, count the number of values. That is simply can represent it as average or simply call it as mean. For example, you have to consider the summation of we have the huge data. Whenever you have to equate, you can find out the value x bar, that is the 1 by, that is the mean value you want to find. X bar equal to 1 by n, summation of from 1 to n, that is the x of I. That is simply can say that that is the mean value in algebraic measure. An algebraic measure can be computed by applying algebraic function one or more distributive measures like mean equal to sum by count. So you know that already average how we can find out sum of the values by number of values. So based on that, we have to find out the mean value. Here also similar summation value and a count. So for example, some cases whenever you have to give in the data, that time you have to find out the X is a weighted matrices. Generally mean you have to find it with the two ways. One is the weighted data and unweighted data. How we can find it the unweighted data? That time you have to use the sum by count. But whereas in weighted data, that time you have to use summation of x of I. That is the weight W of xi by wi. That is the weighted arithmetic mean. That is the outliers. So here you have to say measuring the central tendency. How we can find out the middle value in a holistic measure? Middle value is a odd number of values. If the odd number of values we have, middle value have to represent it as median value. But whereas the values are in the even numbers, that you have to find out the middle two values. We have to take the average. That is the median value. The holistic measure must be computed on the entire document. You have to represent. For example, I want to show mean value you want to find out. Suppose the following. Once you have to see the problem to measuring the mean value and as well as median value. So here I want to consider, suppose we have the following values of the salary, dollars you have to represent in increasing order. That is the $30, 40, 36, 47, 50, 52, 52, 60, 56, 60, 63, 70, 70, and 110. Total how many values? That is the 12 values. Summation of these two values divided by 12. You get the adding all these values, we get the 696 by 12. That is the average on average 58. That is the mean salary of the people is $58. Okay, or 50. Oh, for example, you have to consider as a thousands. So $58,000. This is the unweighted. For example, weighted arithmetic, that time you have to represent a weighted average you want to find out. The summation of wi xi, that is the w1 x1, w2 x2, and so on up to wn xn by divided by weighted values w1 plus w2 plus w2 up to wn. This is the way we have to find out the weighted arithmetic mean. So the median value we have to find out by using the formula, that is the median equal to using this formula I of I, that is the I of, that is the value you have to represent it as L of I, that is the lower boundary. We have to represent L of I plus n by 2, L of I plus n by 2 minus summation of frequency of L divided by frequency median value into width. So by using the formula, you can find out the median value. For example, where L is the lower boundary of the median interest rate, N is the number of value in the entire data set, and summation of frequency is the sum of frequencies. All of the median is the frequency of the median interval, and width is the width of the median interval. So this is the way you can find out the median value. See this example. Here, this is the frequency. What is the median values? That is the 16 to 20, and the frequency is 300. Median interval contains the median frequency. L1 is the lower boundary, and n is the number of values in the entire data set, and summation of frequency, sum of the all frequencies intervals before the median interval, and frequency and width, the median interval. This is the way you can find out the median values in holistic method. So next one, mode value. So in the measuring the central tendency, mainly you have to find out the mean and mode and median values. Mean value you have to represent it as the value that occurs most frequently in the data. Mean value, you know that median value already had discussed. We have to discuss with that mode value. The value that occurs most frequently in the data. Which number is most frequent? That number is called as mode. It is possible that several different values have the greater frequency. That is the unimodal and bimodal and trimodal or multimodal. So these are the four types of modes you have to use. More than modes are called as, that is the mode measuring at a central tendency. So if each data value occurs only once, then there is a no mode. Okay, clear? That is the empirical. How you can find out the value? So here we can find out the value mean minus mode equal to is exactly equal to 3 into mean minus median. So this is the way you can find out the mode. That is simply, for example, you have to see this problem. The mode from the mode, the value is bimodal. For example, let us assume the modes are $52,000 and as well as $70,000. Okay. For the unimodal, so here both are similar. So 52,000, how many times you are there? And similar way, 70,000 also similar way we have to take. This is a bimodal. That is the unimodal, bimodal, and trimodal. And the same frequency. We are getting the 52,000 and 72,000 are both are same frequency. So 52,000 occurs 2 times and 3 times. Similar 70,000 occurs 3 times. So that's the reason there are the two numbers are most frequent. That is the 52,000 and 70,000. That's the way you can call it as it is a bimodal. So for the unimodal numeric is moderately stood up symmetrical way. For example, you have to consider the formula mean minus mode equal to 3 into mean minus median. So this is regarding to that mean and mode, the relationship between the mean and mode and median values. So this is the way you can find out if any one of the value. And the next one is the mid-range value. In the central tendency, can also be used to assess the central tendency. It is the average of the smallest and largest value of the set. You can represent the mid-range. It is an algebraic structure measure where it is easy to compute. For example, the mid-range of the data of a given problem. That is a what is the lowest value of given data is 30,000. Let us assume $30,000, and highest range is $110. Okay, $110. So now here 30,000 plus $110. The average you have to find out, that is the 110 plus 30, that is the 140 by 2. That is you have to get the mid-range value is $70,000. That is the mid-range value you have to find out in central tendency. See, this diagram shows the relationship between the mean and mode and median values. Mean and mode median values is symmetric as positively, negatively screwed up. For example, here we have to consider symmetric data. All are symmetric. The data you have to increase it in a first coordinate, that you have to represent it as symmetric data. And here in the positive screwed up data, that it means when the data is raising to more to positive manner, that is the positive screwed data. So where the data you have to started to negative range, that you have to represent it as negatively screwed data. For example, here you have to see this diagram shows screwed up this data from particular position. It will be reached after that. It will be the data you have to screwed up, that is negative manner. That is simply is called it as negatively screwed data. The mode value is natively screwed. First one is median, and mode. Whenever the positively screwed data, that is the mode is raising the value on particular position, and median value and the mean value. This is the measuring of central tendency. Next one, we can discuss with that measuring of dispersion of data. So in measuring of dispersion of data, mainly you have to discuss with that the degree in which data is trying to spread is called dispersion of variance of the data. The degree in which data is trying to spread is called the dispersion or the variance of the data. The most common measures of the data dispersion are range, the 5-number summary based on that quantiles. Quartiles simply you can represent it as the interquartile range and standard deviation. So here see this measuring of the dispersion of the data. First one, range and quartiles, variance, standard deviation, and interquartile range. So first one, you have to consider the common structure of first one is range. The distance between the largest and smallest values is simply called it as range. The distance between the largest and the smallest values are called range. And the next one is the percentile. That is the kth percentile. How we can say that the value x having the property that k percentage of the data, that is simply called as k percentage. The median value is 50%. The most popular percentiles other than the median value are called quantiles, quartiles, Q1 and 20th percentile, that is the in Q3, that is the 70th percentile. The quantiles plus median value gives some indicator of the certain spread and shape of the distribution. That is simply called as kth percentile of the range. Range. Interquartile range, first and third quartiles. Quadratic equation. Mainly you have to represent the 4 coordinates. That is the Q1, Q2, Q3, Q4. So all positive values you have represented as in Q1. Positive and negative values you have to represent. That is the negative and positive values you have represented as quantile. That is the quartile 2, and the quartile 3 you have to represent the both are negative. You have to represent it as quartile 3, and quartile positive and negative you have to represent quartile 4. So here you have to find out the distance between the first and the third quartiles. That is the IQR equal to Q3 minus Q1. The simple measure of the spread that gives the range of the covered by the middle of the off of the data is simply you can call it as interquartile range. What is the outlier? Outlier is simply call it as 1.5 of the IQR is called as outlier. Usually a value falling at least 1.5 into 1 IQR above the third quartile, below the first quartile. That is simply call it as outlier. So based on that quartiles values, you have to represented these outliers. And next one, another concept is that 5-number summary. 5-number summary means that is simply you can call it as provide the additional information about the endpoints. So a particular data you have to know about the in detail about that data. That time you have to use this 5-number summary. So what is the minimum value? What is the maximum value? And what is the quartile value, Q1 value, and what is the quartile 3 value and median value? These are the 5-number summary of the particular data. So here, for example, you have to take min equal to Q1 minus 1.5 into IQR. That is the min value you have to find out. Whereas maximum value you have to find out Q3 plus 1.5x into IQR. That is the min and maximum values we have to find out by using these formulas. That is regarding to that 5-number summary. Generally, this summary you have to represent it with the box plots. What is a box plot? Means simply you can say that box plot is a proper way to visualize the distribution process. A box plot incorporates the 5-number summary as follows. The endpoints of the box are the quantile, so that the box length is the interquartile range. The median value is marked by the line within the box. 2 lines called as whiskers outside the box extended to the smallest, that is minimum, and the largest is maximum observation. See this diagram shows how measuring the dispersion of data. This is the variance value. You have to find out the standard deviation. Variance and standard deviation. How we can find out the variance value? Variance algebraic science computation value. Variance square equal to 1 by n. 1 by n summation of x of I 1 to n x of I minus mu whole square. That is simply you can say that the variance you can find out the value, and similar way standard deviation. Standard deviation rho is the square root of the variance. So root of the square root of the variance is called standard deviation. Here these are the basic properties of the standard deviation. Rho is a measure spread about the mean and should be used only when the mean is chosen as measure of the center. Rho equal to 0 only whether there is a no spread, that is when all observations have the same value, otherwise rho is greater than 0. Variance and standard deviations are algebraic measures, thus their computation is scalable and large databases. So this is regarding to this one, that is the box plots. And the box plot is simply you can say that is a graphic display of the 5-number summary in box plot. And second one, histograms. Histograms we have to represent in x-axis or values, y-axis are represented and frequencies. Scatter plot. Scatter plot is represented each pair of the values is a pair of coordinates and plotted as pointers in the plane. See here, this is the box plot detail. The fine number is summary of the distribution. We have to represent it here. The minimum value and maximum value and Q3 value and median value and Q2 value. So see here, this is the maximum value, and this is the Q1 value, and this is the Q3 value. This is the median value. So you have the 5 points. One is the add minus 3 row. The one we have the 1 point, and this is the maximum value. It is the quartile 1 minus 1.5 into IQR. Already you have to see this formula in the previous slide. And the next one is the maximum. Who can find out the maximum value? Q3 plus 1.5 into IQR. Okay, clear? So this is the way you can find out the minimum and max values. Here you can represent the first coordinate, that is the Q1 value, that is the Q1, and that is the minus row, that is a row you have to represent it as Q1, and Q3 is represented as quarter 3, Q3. The distance between these Q3 minus Q1 equal to IQR. So in middle value, that is by 2, you have to represent it as median value. This is the 5 number summary of the distribution. You have to represent it with the box plot. What is the box plot? Box plot you have to box plot we have to represent it as data is represented with a box, and it ends the ends of the box are at the first and the third quarter. The height of the box is IQR. The median is marked at a line within the box. Whiskers, there is the 2 lines outside the box extended to minimum and maximum. The outliers are points beyond the See here, often tell more than box plots. The 2 histograms shown in the left hand may have same box plot representation. The same values, so we have to represent minimum value Q1 and the median and Q3 maximum value, but they have the rather different data distributions. This is the scatter plot. It's a bivariate few clusters of the points in outliers. Each pair of the values is treated as a pair of the coordinates and plotted as points in a plane. So where the data you have, that data you have to represent it as a point. That is the scatter plots. So the unit price of the all products, all the items you have to represent it here. So each product you have to represent it that item sold. That you have to represent it as block, that is a lakhs point you have to represent it. That is the scatter plot. So see, this is a positively negatively correlated data. This is a whenever you have to increase this towards this y-axis, that you have to represent it as positive correlated data, and if it comes to the negative to the x-axis, that is the neutrally correlated data. That is the left of the fragment is represented as positively correlated. The right of the negative data is called as neutrally correlated. So this is uncorrelated data. We have the no positive and negative. So we have the anywhere the data we have to place. That is regarding to this one. We'll continue in next class. That is how to measuring the data similarity and dissimilarity. We'll continue in next class. We'll take that next. Please wait 10 minutes. Thank you.